Hello and welcome to another fun-filled adventure with Mr. Sims in Algebra 1. This video is simplifying exponents. Yes, we are now today going to tackle simplifying exponents. If you have not watched the other video which talked about the exponent rules, I do highly suggest that you watch that because it'll make everything a little bit easier for you. We're actually not going to go over the rules. We're going to assume that you already know them, that you learned them in class or you learned them elsewhere. But once again, if you need a brush up on those rules at length, you can go in depth rather, you can go to the other video, which is I believe called Basics of Exponent Rules or something like that. So this right here is simplifying exponents, and just a quick refresher, we're going to be using some of these rules here, so I'm just going to go over them super fast, just the basic of them. The zero exponent rule says a to the 0 is equal to 1. It doesn't matter what you have to the 0 power, it's equal to 1. The power to a power rule says that if you have a to the m to the power of n, that your answer is going to equal a to the m times n. Okay. The negative exponent rule says that if you have a to the a to the negative n, that's the same thing as saying 1 over a to the n power. It's the same exponent, just once again flipped over the fraction bar. And that the next one is apply the product rule. The product rule says that if you have a to the m times a to the n, that you have a to the m plus n. And then finally, the quotient rule here is a to the m, a to the m over a to the n is really the same thing as saying a to the m minus n. Okay, and that's just a quick refresher in case you've forgotten these. These rules, by the way, in case you're wondering, you will see these rules on your star reference chart when you're taking tests and when you take the EOC at the end of the year. So look for those rules if you do get confused, and get used to reading them like that, and it'll help you out a lot. Finally, the last one says raise each coefficient to the appropriate power and simplify fractions. This should be simplify fractions. And what that means is basically we're going to just look and see if there's a fraction in the problem that we can simplify to make things easier, and any coefficients in the problem that are raised to a power, we're going to finish doing that. So these are 6 steps that will significantly help you succeed in these problems. You can commit them to memory. You can, I don't know, just do like zebras, protect, nerdy, phoenixes, quietly rampaging or something. I don't know, however you want to remember it, but the whole point is you gotta try and get these steps down, and you don't always have to go necessarily exactly in this order, but it'll be a systematic way for you to get it right. My suggestion for you at this point is to please write down these 6 rules. I'll go ahead and pause the video and write them down, because you will be referencing them as we go each of the problems. So go ahead and do that. All right, hopefully you did write down the 6 rules. Remember, whenever you are doing any video that we have here in Algebra 1, you desperately need to actually do the problems. If you are just watching the video, then I gotta admit you're kind of wasting your time, and you're also inoculating yourself against wanting to watch it later. So what you think happens is, oh, I already watched that video, but really you didn't take the information in if you're not actually doing the problems. Your retention probably, if you're not doing the problems, is, I'm guessing, maybe 10% at the highest. Maybe if you're a super great listener, 20%. But really, honestly, you're moving that up to probably close to 80% if you actually do the problem. So once again, right now, grab a piece of paper, grab a pen, and get ready to start. All right, hopefully you have a paper and pen handy. Once again, make sure you are ready to go, and we're going to start with this little problem here. I'm going to zoom it. Whoa, that was ugly. Let me try that again. I'm just going to zoom into this problem so we can get started. So we have 4x cubed times 2x cubed, and we need to simplify that with no negative exponents left. So I'm going to go one step at a time through those steps that I gave you. The first one is apply the zero exponent rule. Well, there is no zero exponent, so I can't apply that rule. So I apply the power rule. Well, there's no power rule. There's no power to a power, so I'm done with that one. The next one's apply the negative exponent rule. Well, there is no negative exponent, so I'm done with that one. Apply the product rule. There is the product rule. So what I'm going to do is I'm going to multiply the things that I can together. I have these two coefficients, 4 times 2, which are going to give me 8, right? But then I also have x to the x cubed times x to the cube. And remember, the product to power rule means that I end up having x to the 3 plus 3. Because if I multiply the same base exponents, I just add the exponents together. And that's going to give me x to the 3 plus 3. Pardon me there. So that's going to give me, when I simplify it further, 8x to the 6. And that is my final answer for this problem. Let me double check to make sure I did not do anything wrong. Yep, I'm good. All right. So I've written the answers down elsewhere to make sure that as I'm teaching you, I don't accidentally mess up. Here we go. Let's go ahead and do, I literally have not done any of these problems beforehand. All I have is the answers somewhere. So you are actually watching me think through each problem with you. How fun is that? Pretty cool, huh? So, okay, so this one is the second problem here. This is 2c, this is 2c d to the fourth squared cd to the fifth. So once again, I'm going to go through that list that I gave you earlier. So we're going to apply the zero exponent rule. And if you apply the zero exponent rule, you'll notice there are no zero exponents. So we're done. Okay, so now we apply the power rule. We do have the power rule. So the power rule says that I can basically distribute this 2 to everything inside here. So what I have, I'm just going to rewrite it. I have 2... inside the parentheses, I have 2 squared c squared d to the fourth, and that has to be squared, right? And then I have, on this side, I have that all multiplied times c, once again distributing the 5 in there, and I get c to the fifth, and times d to the fifth. All right, and that's kind of ugly, but it's a good start. All right, so I've applied the product rule now. Now I'm going to just simplify it a little bit. So I basically have 2 squared times c squared, right? All I did was do that. This one here, this power to a power rule is what I'm going to apply now. The power to a power rule says d to the 4 to the second power is, I'm going to multiply those to get my answer. So I get d to the 8th times c to the 5th times d to the 5th. Okay, so that's a lot of stuff there. So I've applied the power rule. Now I'm going to apply the negative exponent rule. There are no negative exponents, so I'm good. So now I'm going to apply the product rule. So I'm looking for my same base things, and if they multiply together, I'm going to add the exponent. So in this case, my 2 squared does not, so I'm going to leave my 2 squared as it is. But my c, I have this c and I have this c. So I can multiply those two together and get c to the 7th. Right? And then I have d to the 8th, d to the 5th, so that's going to give me d to the 13th, because d to the 8 plus 5 is going to be 13. Okay? So once again, that step, in case you were wondering what I did, I took c to the 2 plus 5, and that's what gave me this 7 here. And then I also did the same thing with the d to the 8 plus 5. I didn't want to skip any steps and confuse anyone there, okay? All right, so this leaves me with this here. So I've applied the product rule. Now I'm going to apply the quotient rule. Well, there is nothing being divided here, so I'm good. So now I'm just going to raise each coefficient or number to the appropriate power. Well, 2 is raised to the second power, so 2 to the second power is 4. And I get 4, c to the 7, d to the 13. And I am done. Bada bing, bada boom. All right, that is my final answer, and indeed it is a beautiful answer. I love it. All right, hopefully those have not been too difficult for you. Don't forget to pause and try these yourself as you go, because if you're not trying them yourself, you're not really learning. Go ahead and give this a shot with those rules that I've given you earlier. All right, hopefully you actually paused the video and gave this a shot. If you haven't paused the video and given it a shot, then I highly suggest you do that now. So in this problem here, first of all, I'm going to look for the first thing step says to look for the zero exponent rule. I can't apply it here. There is no zero exponent rule. There's no zero exponent, so I can't apply the rule. So now I'm going to apply the power rule. The power rule says if I have something raised to a power, I don't have anything raised to a power, so okay, now I'm going to apply the negative exponent rule. Are there any negative exponents? No, in fact, they're all positive here, so that doesn't help me either. So now I'm going to apply the product rule. Well, there is no product rule. There's nothing of the same base being multiplied together here. There's an x and a y, but they're not the same base, so I can't do anything with them. So now I have applied the quotient rule. Well, with the quotient rule, I can do it. Here I have x squared divided by x to the, don't forget, this is the 1 power, right? And here I have y to the 5th divided by y to the 4th. Well, the quotient rule tells me then that's going to be x to the 2 minus 1, because I would subtract these two exponents here. This one, I would subtract this number from this one, so x to the 2 minus 1, and then I would get y to the 5 minus 4. And if I do that, if I simplify that one more step, I get x, and then I get y. Yeah, x to the 2 minus 1 is 1, right? And y to the 5 minus 4 is also 1. But I don't need to write those two ones. I can just write x times y. And that is indeed my final answer. Hopefully you were able to get that on your own. If not, just keep working at it. Let's see if we can do some more. Hopefully you're having a little bit of fun as we do these too. Feeling your confidence build as you get harder and harder. We will get harder and harder with these problems, so just bear with me and let's go through the steps together. Alright, so go ahead and pause the video and try this problem here. See if you can do it. I think you can, so just give it your best shot. Alright, so what we have here is we have this ugly little problem, but it's also a cool little problem. And what we have is we have 5x cubed y 20xy to the 5th, all that to the 4th power. So let's go ahead and start with the first part. It says apply the zero exponent rule. There is no zero exponent in this case, so don't have to worry about it. Now I apply the power to a power rule. Wow, there's actually a lot to go to the power to a power here. So let's start at the top. I have 5. I'm going to raise this 5 to the 4th power, right? So I have 5 to the 4th power. I have x cubed being raised once again to the 4th power. And I have y being raised to the 4th power. And you might think that that's it. But actually, if you look on the bottom, all of this needs to be raised to the 4th power as well. So I have 20 raised to the 4th power. I have x raised, oh sorry, this is 20 raised to the 4th power. Do use your parentheses. It's going to save you a lot of grief in the long run, okay? So x raised to the 4th power, and finally y to the 5th raised to the 4th power. So that's the power to a power rule. I've just applied it basically throughout. I just need to simplify it a little bit. So I basically end up with 5 to the 4th, right? I end up with x, 3 times 4 is 12, x to the 12th. I end up with y to the 4th, all over 20 to the 4th power, times x to the 4th power, times y to the 20th, because 5 times 4 is 20. So once again, 3 times 4 gave me the 12 here. 4 times the understood 1 gave me 4. And then x to the 4th, once again, likewise, from 4 times 1 and 4 times 5 is 20. So what I did was I just applied the power to a power rule. So now I'm going to apply the negative exponent rule. Are there any negative exponents? No, there's none. So I'm going to apply now the product rule. There's no product rule because none of these that I can multiply times have the same base, right? So now I'm going to look for the quotient rule. Well, the good news is there's tons of stuff we can do with the quotient rule. As you can see, we have x to the 4th and x to the 12th. Well, that tells me that what I have here is x to the 12 minus 4, right? And then I also have y to the 4 minus 20, right? And then I have these things here, which are just a mess, right? I can actually, I've actually pulled these x's and y's up here, so I can actually remove those from the bottom now because they got, with the quotient rule, they ended up being removed, right? So I end up with 5 to the 4th, and on the bottom I have 20 to the 4th, okay? So this problem so far right here, it looks a little bit ugly. Let me simplify it a little bit. 12 minus 4, as you know, is x to the 8th, right? 4 minus 20 is going to be negative what? Y to the negative 16, right? Okay. So that's y to the negative 16, and then I still have my 5 to the 4 and the 20 to the 4, and both of those are pretty ugly, I gotta admit. So what we have here now is we have x to the 8th, y to the negative 16. Now, as you remember, you cannot leave a negative exponent in your final answer. So what I'm going to do is I'm just going to move that negative exponent to across the fraction bar, and that's going to make it positive. It's going to keep the same exponent, except it's just going to turn positive. So my new answer is going to be 5 to the 4 x to the 8 all over 20 to the 4 y to the 16th power. And that right there is almost my final answer. I'm not quite done yet. What I then have to do is actually raise these powers to the right power. So 5 to the 4, if I type that into my calculator, I'm going to get a big number, but it's not even going to be the biggest number I'm going to get here. Let's see, 5 to the 4 is 625. I'm just going to make this equal to, is equal to 625, right? X to the 8th all over 20 to the 4th. 20 to the 4th is 160,000. And at this point, you're like, that is just insane. And you are absolutely 100% right. That is insane. 160,000 y to the 16th. But the good news is, there was a way that we could have made this simpler before we ever started. And if you reduce this fraction, by the way, it is a little bit of a pain in the bottom to reduce. I would start by like dividing it by 5, or just stuff that works. And when you do the final reduction in it, you end up getting 1 on the top, so you don't have to write it, and you end up just getting x over 8 is equal to 256 times y to the 16th. Now, the way that you would do that, once again, 625 divided by 5, and then you have to do the same to the bottom. You keep going until you reduce the fraction to basically it becomes 1 over 256. But I want to show you that you could have actually done that way earlier when you first started the problem. You had the fraction here, 5 over 20. So the smart place to do it would have been right here. Because if you did it here, you saved yourself all this garbage here. So 5 over 20, both of those can be divisible by 5, right? You divide the top by 5 and you divide the bottom by 5, and you end up getting 1/4, right? So that 1 basically just goes away. So you end up with doing this problem instead. X cubed y times 4x y to the 5th. And this is your new problem that now you're raising to the 4th. Erase this here, that's not important anymore. but I just wanted to show you that that was actually how I would have done it. This is just insane. I would never try and put myself through that, right? Can you do it? Yeah. You just keep dividing until you get a fraction that is basically ends up being 1 256. But if you start here, then now you just have to worry about the 4 to the 4th because you already did the reduction here. So in my opinion, this is the better way to do it, and it will take you more directly to this answer here, which is your final answer. If you want some help reducing the 625 and the 160,000, I'll just do it for you real quick. You have 160,000, sorry.
And I'm going to divide the top by 5. 625 divided by 5 is 125, so that already gives me 125, and that's 160,000 divided by 5. And that gives me, oh, not divided by 45, divided by 5, 160,000, darn it. Divided by 5 is going to be 32,000, right? And as you can see, I can keep dividing by 5. I would divide by 5 again. You know, I divide by 5 again. I get 125 divided by 5. I'm just dividing by 5 just because it's easy. And I get 25, right? And then I get 32,000 divided by 5. And I get 6,400. And then once again, I can divide again by 5 and so on and so forth. I think you understand the process until you get to 1 over 2 to 6. I don't want to waste your time
here. So I'm just going to move on to the next problem at this point. But if you keep reducing it, you do get the 1 over 256, like I said. So hopefully that made sense to you. Let's move on to the next problem in the interest of time. And this problem here is x to the negative 2, x to the negative 3, all to the raised to the 4th power. All right, so this one here, once again, we're going to start. Apply the zero exponent rule. There are no zero exponents to apply. So now we apply the power rule. Well, we do have a power to a power. We have x to the negative 2. So this is x to the negative 2 to the 4th power times x to the negative 3 to the 4th power. Now, right about now, you might be screaming, Mr. Sims, why didn't you do this in here first? And that's an excellent question. If you notice that you could do that step first, then that absolutely 100% works and actually gets you the answer a little bit faster. But since I already went with this step and I'm starting with this step and I gave you the rules earlier that you could follow, I'm just going to show you that you could get through it with this step. So I'm just going to keep going. So I get x to the negative 8 and I get x times x to the negative 12, right? And these are both multiplied together. Now, that's the power to a power rule I've just finished. I applied the negative exponent rule. There is a negative exponent rule. So I'm going to put both of these over x to the 8th, x to the 12th. And what I did was I just took this negative 8, this x to the negative 8, because it's a negative exponent, I flip it to the other side of the fraction bar, right? And it becomes a positive exponent. So once again, this one did the same thing. So now I have the same thing, it's just over the fraction bar, right? On the other side of the fraction bar. So now I'm going to apply the product rule. And I multiply these two together, which means I actually end up adding them, which gives me 1 over x to the 8 plus 12, which is once again 1 over x to the 20th. And that is my final answer. Once again, hopefully you actually paused and tried that one. That was one you definitely could get on your own without any help whatsoever because you are just that amazing. So let's go ahead and move on to the next problem, which is this problem here. This problem here is problem number... All right, so for this problem here, once again, we're going to do each of the steps, right? Let me just make sure I got that one right. It was 1 over x to the 20, which is in fact correct. Perfect. All right, so now we're on problem number 6. That's the problem we're on. So problem number 6 says n to the third power times 2n minus 1. And so what I'm going to do, once again, is apply the zero exponent rule. There is no zero exponent, so now I'm applying the power to a power rule. Well, I have n to the 3 to the third, nothing here, so n to the 3 to the third is going to be n to the 3 times 3, right? Times 2n minus 1, and this simplifies to n to the 9th power times 2 to the n minus 1, right? Now I'm going to apply the negative exponent rule. Do I have any negative exponents? And in fact, I do have a negative exponent. I have n to the negative 1. So what I'm going to do is I'm just going to flip the n to the negative 1 to the other side. I'm sorry. I have n, so I have n to the 9 on top. I still have it multiplied times 2, and I have that over n on the bottom. So I have n to the 9 times 2, n to the bottom. What I did is I took this n, which was multiplied times all this, and I just flipped it over the fraction bar, and it keeps the same exponent, which is 1. But since that 1 is understood, I just didn't write it. So I have n to the 9 times 2 over n. And at this point, I have to apply my product rule. I don't have anything that I can multiply times itself, really. So now I'm going to apply the quotient rule. And if you guys don't mind, I'm just going to move this 2 here because coefficients usually go in front. So I'm just going to do that in this next step here. So once it's going to be 2 to the n, 2n to the 9, sorry, over n. And now I'm going to apply the quotient rule, which tells me that if I have this number divided by this number, that this base divided by this base, then I'm just going to subtract the exponents. So I have 2n to the 9 minus 1, because once again, the exponent there is 1. And so I have 2n to the 9 minus 1, which is 2n to the 8th. And that is my final answer. Ta-da! Hopefully you're feeling really good about these at this point. I really hope you are. If you're not, maybe just rewind it and see how I did it and see if you can figure out what's going on. Or there are always tutorials where we can just deal with cool stuff. So let me go ahead and move to the next problem here. This is going to be problem number 7. I'm just going to write a 7 so I just remember for me. That's just important. So problem number 7 starts off with this expression here, and I have 3n squared over 3n squared squared. And I just want you to know that this simplifies really easily. I'm actually going to do it the long way, and then I'm going to show you that actually if you just thought about it a little bit, it would have been so much easier for you. But let's go ahead and look at it really quickly. So what we have here, we apply the zero exponent rule. There are no zero exponents. We apply the power to a power rule, and I end up with 3n squared on top doesn't change, but I end up on the bottom with 3 squared, and then I have n squared squared. And so now I apply the power to a power rule here, and I get 3 squared here. What am I doing? Sims? Let me try that again. So I get 3n squared all over 3 squared, and this is n to the 2 times 2, which is n to the 4. Once again, 2 times 2, right? N to the 4. And I have here 3 squared n to the 4th, right? And now I'm going to do my product rule. There's no products I can multiply times each other, right? So now I'm going to apply the quotient rule. Well, I have n to the squared over n to the 4th, so that's going to give me let me see. So I have 3 over 3 squared, and this is going to be n to the 2 minus 4. So that's going to be, I'm just going to do it over here. I'm running out of room. So 3 to the n to the negative 2 power all over 3 squared, right? And now I apply the negative exponent rule to get this out, because I can't leave any negative exponents here. And so I went back a step, right? But the reason I went back a step is because I have this negative exponent here. So now I end up with 3 all over 3 squared n squared, right? And now I just simplify that out, and I end up with 3. I have to raise my coefficient to the right power. So now I have 3 squared is 9 n squared. So I should have 3 over 9n squared, but I'm not done, because what you see is I have 3 over 9. Well, 3 over 9, as you know, can be simplified. 3/9, if I had a fraction, I'm just going to write the fraction right here. 3/9 simplifies by dividing both sides by 3, right? Both the top and the bottom by 3. I end up getting 1/3. So this is 1/3 n squared. And that right there is my final answer. But I'm going to show you that there was a much easier way if you'd actually just kind of thought about it. And the way you look at it is this. Notice this is 3n squared, and this is 3n squared squared. So the way you could think about it is I have 3n squared all over 3n squared times 3n squared, right? Because that's what the squared means. I'm taking all this stuff and I'm multiplying it times itself. 2 copies of this multiply times itself. So notice this 3n squared cancels out with this 3n squared, and I'm left with 1 over 3n squared. And just sometimes, if you just think about it a little bit, you'll save yourself a whole lot of time. All right, let's go ahead and move to the next problem here. That was 7. I think I'm down to the next section now, which is 8 here. So 8 is, this one actually doesn't have any variables, and after doing all that with variables, this might freak you out a little bit. But let's see if we can not type this into the calculator with all this messiness. Let's actually see about simplifying stuff. So if we're going to do this, we have 2 squared to the 3rd power. So once again, I'm going to apply the 0 exponent rule. Look, we finally, for the love, we finally have a 0 exponent. Yay! So all I'm going to do is change this 0 exponent to 1. It becomes 1. So all of this is multiplied times 1. Basically, that makes it kind of drop out. Since it's all being multiplied, I don't need it anymore. So I have 2 to the squared, 2 squared to the 3rd times, you know what, I'm not going to skip this step. I'm just going to write it for you. Times 1 times 2 to the negative 2, right? And then that 1 just drops out. So it becomes 2 squared to the 3rd power times 2 to the negative 2. Well, now I apply any power to the power rule. Well, this is 2 to the 3rd power, so this is 2 to the 2 times 3, right? That's how we've been doing it. 2 times 3. I just wrote it out this time. 2 to the 2 times 3 times 2 to the negative 2. And now I do 2 to the 2 times 3 is going to be 2 to the 6th power times 2 to the negative 2, right? And now my next step is to take, and because these both are multiplied times each other, I actually add the exponents. So I get 2 to the 6 plus a negative 2, which is the same as subtracting 2. And I get 2 to 6 minus 2, which is the same as 2 to the 4th. And that is actually a lot easier to do than if I tried to type in this big mama jama. So what I have is 2 to the 4th, which I can type in easily to my calculator. And 2 to the 4th, well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that should be 16. So 2 to the 4th is equal to 16. And my answer, let me make sure I'm right here. This is question number 8. And in fact, yes, the answer is 16th. You could also, just so you know, you might see it left sometimes as 2 to the 4th on a test, because technically that is simplifying this, but I just went all the way to 16 just for kicks and grins. But anyway, hopefully that made sense to you. All right, that is question number 8. Can you believe we had done 8 problems together? Well, I hope you're having a ball with it. Let's go ahead and do the next one here, which is, oh, let me try that again. 9. Problem number 9 is, yeah, there we go. Yeah, look at that ugly one. Yeah, it's beautiful. I love it. It's not really ugly. It's beautiful. It's a thing of beauty. So that's number 9. Question number 9, the way you get the answer here is you look at it very carefully, and then you cry a little bit, and then let's figure it out. So question number 9, we're looking at, okay, let's do it. So what you have here is you have a lot of stuff. Let's go through the steps. When you get something like this, it's easy to freak out, but you really shouldn't, because as you're doing this, you really have the opportunity to just to excel if you just take the steps one at a time. Okay, so I'm going to apply the 0 exponent rule, and I see one 0 exponent here, right? So what I have here is, I'm just going to rewrite it. I have negative x on top all over x to the negative 2, right, times times negative, and since this was y to the 0, it just becomes a negative 1, right? Times x to the third, y to the fifth, all right? To all that to the third. And I've got to clean something up right here because it's going to drive me bonkers if I have to just keep writing this right here. So what I'm going to do is I'm going to recognize this is negative 1, and this is already a negative here. I'm going to multiply this negative times a negative to get a positive. And so what I'm going to do is I'm going to just rewrite this without the negative sign. I don't need it anymore. And I'll also simultaneously get rid of this negative 1 because the negative times the negative is a positive, all right? So I'm going to get x over x to the negative 2 times x to the third, y to the fifth, right? All over 3. Okay, and I've got to erase that. That's just bothering me too. Let me just erase. And let me rewrite that now. All right, so there's the line. Okay, so now what I'm going to do is I'm going to follow the steps a little bit more. I just needed to deal with that because it was really bothering me. So apply the power to a power rule now. What I have is I have x that I'm going to raise to the third power. So that's going to become x to the third power all over x to the negative 2 to the third power times x to the 3 x to the third power to the third power again, y to the fifth, once again in parentheses, to the third power. And I want to stress to you the importance of using parentheses just for your sanity as you get further into algebra, but also it will help you keep things correct, especially once you start working with negatives a lot. So now I have x to the negative 2 to the third power, and once again I do that by just multiplying them. So I get x to the negative 6. Oh, what am I doing? Sorry, I forgot the numerator. So I have x to the 3. I'm just going to move this down just a hair, okay? I have x to the 3 all over. That's an ugly line. There we go.
Did you mean play the song 3?
X.
Noisy feast day is all over?
Alexa, stop. Alexa didn't understand what I was saying. So x to the 3 over x to the negative.
I didn't find a device named understand.
I hate my Echo Dot right now. So x to the 3 over x to the negative 6 is x to the, this is x to the 9th times x to the 9th, and this is y to the 15th. And once again, I got those by multiplying negative 2 times 3, 3 times 3, which is 9, and 5 times 3, which is 15. So now that is the applying the power rule. Now I apply the negative exponent rule. Notice I have a negative exponent now, so I can move it to the other side of the fraction bar, and I'll get, I'm just gonna, let's see, I can probably just move this up, zoom in a little bit. So now I can get x to the third, let's try to write this just a hair neater for you guys, times x to the 6, right? And on the bottom, I'm still left with x to the 9th, y to the 15th. All right, so I've applied the negative exponent rule now, and now I'm going to apply the product rule. I look at what can be multiplied. Well, as you can see, these two can be multiplied together. That's going to give me, and if I apply the product rule, remember I add the numerators when I multiply these two of the same base together. So I get x to the 9th power all over x to the 9th. Let me write that 9 a little bit. So there we go. Y to the 15th, right? And that's applying the product rule. Now I apply the quotient rule. Notice I have x to the 9, x to the 9, so I can actually do this step where I get x to the 9 minus 9, or you might have just realized they cancel out, and that's fine too. But I'm just going to do x to the 9 minus 9, y to the 15th, and that's going to equal x to the 0, y over y to the 15th, which is really equal to 1 over y to the 15th. Ha-ha! Excellent. Isn't that fun? Isn't that fun that all of this ugliness here Look at that beast. Oh, it's ugly. And all of that boiled down to this cute little 1 over y to the 15th. Isn't that, you know what? That deserves a little bunny. Here's a little bunny just for you. There you go. Look at the bunny. He's so happy to be with you right there. Okay? I don't want to waste any of your time, so I'm going to move on. All right, that's his buck teeth. All right, so 1 over y to the 15th is the correct answer there. Let's go ahead and move on to the next problem. I'm just going to go ahead and move over there. This is my next one, and notice it's also a little bit ugly, but let's go ahead and do these steps one at a time. Here we go. So I'm going to apply the zero exponent rule. Okay, I apply the zero exponent rule here, and I notice that this is a zero exponent, so that simplifies, right? So I end up with negative 7a squared b cubed. That's a b cubed, and that's times 1. I don't need to write the times 1 since it just goes away. And that's all over, that's all over 3a cubed b 4c3, right? And all of that to the negative fourth. So now I'm going to do the power to a power rule, and so I get negative 7 to the negative fourth power, right? And I get a squared times a squared to the negative fourth power times b to the 3 to the negative fourth power. And if these are getting progressively difficult and you're keeping up with them, kudos to you, because these are actually getting into stuff that's probably more difficult than we're going to see in Algebra 1. So we're getting 3 to the negative 4. You might see something this difficult, but we're going to get to problems that are even a little bit more difficult. So we get 3 to the negative fourth power times a3 to the negative fourth power times b to the fourth to the negative fourth power, okay? And this is c to the 3 to the negative fourth power, all right? And this right here is what you have. And what we're going to do is we're just going to now do those power to powers. Whew, this is going to be negative 7, right? I'm just going to leave it negative 7 to the negative 4 because otherwise we might get confused with that negative sign. I'm just going to leave it like that for now. A squared to the negative 4, I can make negative a to the negative 8, right? This a to the negative 8. This is b cubed to the negative 4. That's negative b to the negative 12. Once again, I got that by multiplying 3 times a negative 4. And then I get 3 to the negative 4 on the bottom. I'm just going to leave that 3 to the negative 4 power, right? I get a 3 to the negative 4, so this is once again a to the negative 12th power, right? And this is b to the negative 16th power, right? And this is c to the negative 12th power. That's a lot of negatives, right? So when I get to this next step, applying the negative exponent rule, I have my work cut out for me. So here's what I'm going to do. I'm just going to move some, give myself some space there. And what I have here is I have negative 7. Negative 7 to the negative 4 is going to move to the bottom. Let me go ahead and write my fraction bar, and I'll just start moving stuff as I go. So I have negative 7, and this is to the fourth, okay? And this is a to the negative 8, so this is going to be a to the 8th down here. This is b to the 12th because it goes over the fraction bar. And then this 3 to the negative 4 flips up on top, so it becomes 3 to the 4th. This a to the negative 12th becomes a to the 12th. Notice a lot of stuff is just switching places in this case. B to the 16, and finally c to the 12. In fact, the whole thing flipped over itself. That was kind of cray-cray. So, all right, that right there is the negative exponent rule applied. So now I apply the product rule. Well, there's nothing to apply for the product rule. So now I apply the quotient rule. And what I have here is I have a to the 12 over a to the 8th. So that's going to give me 12 minus 8 is a to the 4th. All right, I'm not going to just write it this time. I'm just going to do it, and I'm not going to write that intermediate step of a to the 12 minus 8. I think you know it by now. So 12 minus 8 is 4. B to the 16 minus 12 is b to the 4th as well. And c to the 12th is just going to stay c to the 12th because there's nothing else to multiply time. And now I have 3 to the 4th, negative 7, all over negative 7 to the 4th power. Now, I've applied my quotient rule, so now my next step is to raise each coefficient to the appropriate power. And for this, I'm going to need my calculator because I don't know what the 4th root of 3 is off the top of my head. So I'm just going to type it in. 3 to the 4th power is equal to 81. So now I have 81 on top. This is equal to 81. 81 a to the 4th, b to the 4th, c to the 12th, right? And this is negative 7 to the 4th. And once again, I'm going to type it in my calculator. But do not forget, when you type it into your calculator, you need to type in the negative 7 all inside parentheses and then raise that to the 4th. Otherwise, it's going to think you just want to raise the 7 to the 4th and multiply it times like a negative 1. And that's not what you want. So you want negative 7 to the 4th power. So I'm going to put in my parentheses negative 7 to the 4th power. And I get 2,401. That is unbelievably ugly. It really is. This is horrible. But it works. So let's see here. We have 81 over 2,401. A to the 4th, b to the 4th, c to the 12th. And that right there is a answer, but it's a really ugly answer. Let me see what I think we might have to simplify that fraction, and that's just going to be a pain in the tuchus. So no, actually that is it in simplest form. We're already good. Oh, thank heavens. I was concerned we were going to have to simplify that mamba jama. So we have let's see, 81 a to the 4th, b to the 4th, c to the 12th, all over 2,401. I got it right. It feels so good to get it right. I love it. Hey, I told you I was doing these with you guys. Of course, I get stuff wrong sometimes, but not very often, but sometimes. So moving on, let's go to the next problem here. Except it's not on this line. I have to move to the next line. Ding. All right. So here, this one here, let's go ahead and do it real quick. So once again, applying the zero exponent rule, there is a zero exponent here, so I get negative 2a3 b squared all over, what am I doing, Sims? All over 3a squared b cubed c to the 7th, right? And all I did there was applied the zero exponent rule. Now I apply the power to a power rule because all of this is raised to the negative 2 power. I'm going to multiply everything, distribute this negative 2 to everything on the inside. So I get negative 2 to the negative 2 power. I get a to the 3 to the negative 2 power, b squared to the negative 2 power, all over 3 to the negative 2 power, a cubed, no, sorry, a squared, that's a squared to the negative 2 power. Let me just rewrite that. I don't like that. Okay, a squared to the negative 2 power. I don't want that to be confusing for you guys. b3 to the negative 2 power, and c to the 7th to the negative 2 power. You have that right there, and what you should have based on that is I've basically done that. Now I just got to actually do the raising to the powers. So I get, let's see, I get negative 2 to the negative 2. I'm just going to leave that like that for the moment. I get a3 to the negative 6, which is going to be a to the negative 6, and I get b to the negative 4th, right? And I get 3 to the negative 2, and I get a squared to the negative 2, which is a to the negative 4, right? I get b to the negative 6, and I get c to the negative 14. Once again, I got all those by multiplying these exponents together, because that's what you do with the power to power rule. So now the next step is to simplify. The next step is to, let's see, apply the negative exponent rule. So I'm going to start flipping stuff to the other side. So I get let me write my fraction bar. I get negative 2, my negative 2 to the squared power. I get a to the 6, right, because it goes to the other side, and I get b to the 4th. And on top I have 3 squared, right? I have a to the 4th, b to the 6th, and c to the 14th. And then I do the quotient rule, right, which is to subtract the like bases. So I end up with 3 squared. I can subtract my a to the 4, my a to the 6, and I get a to the negative 2, right, which I can actually, I'll just write it up here, a to the negative 2, right? I get b, let me get rid of that fraction bar actually, that's going to make it more confusing. I get a to the negative 2, right? I get b to the b squared, 6 minus 4 is squared, 2, sorry, and c to the 14, nothing changes there. And over the top that, I can't forget this negative 2 squared, so I get negative 2 squared, all right? And that still looks pretty ugly, but at least I'm making progress. So now I can apply the negative exponent rule again to make this go to the other side, and I get, let's see, I get 3 squared, sorry, 3 squared, I get times b squared, c to the 14, and I'm going to c to the 14, right? And I'm going to move this a to the other side, so I get negative 2 squared, what just happened? Negative 2 squared times a to the, what is that? Times a to the squared. There we go. So this right here is already pretty much more simple than it was before. I applied the product rule, I applied the quotient rule, and now the only thing to do left is raise these to the right coefficient. So 3 squared is equal to 9, right? So I have 9b squared, c to the 14th, and this is negative 2 squared. Negative 2 times the negative 2 is a positive 4a squared. And that should be my final answer, because 9/4 can't really be reduced here. So I should get that. Can't be reduced. And in fact, my answer is 9b squared c to the 14th, 4a squared. I am correct. Haha! Feels so good. All right, so that's the final answer, that ugly thing there. All right, so let's go ahead. We have just a few more problems to do. Two more problems to do, and one big mama jama that you can challenge. It's your challenge problem that you can do if you would like to. You don't have to, but it's always good to challenge yourself. So here we go. We have negative 4 x cubed is, let's see. So once again, I applied the zero exponent rule, and in this case, look at all this junk that just goes away with that beautiful little zero exponents. You're gonna learn to love seeing zero exponents, because it will just make you happy. It just will, because it just goes away. So negative 4x cubed y to the negative 1 all squared, right, over 2x to the 4th y all cubed. And oh my gosh, that already looks so much nicer because of this beautiful zero exponent. We should give it a kiss. Mwah. Mwah. There we go. We love you so much. Yes, hearts everywhere. There you go. So negative 4x cubed y to the negative 1 squared. And what we have here, we're going to apply the power to a power rule. So we get negative 4, right? Let me zoom in a little bit to make this easier. So I get, what is that? That is just ugly. So negative 4, That's going to be squared raised to the second power times x cubed raised to the second power, y to the -1 raised to the second power. That is so ugly, Mr. Sims. You get the idea, though. So y to the -1 raised to the second power all over. I can do it on the bottom, too. I got 2 raised to the third power, x to the fourth. Because there's no negative or anything like that, well, you know what, let's just be consistent. X raised to the x to the fourth, or sorry, raised to the third power, and y to the 1 raised to the third power. And when we simplify that further, we get -4, once again, -4 squared, x to the 6th, y to the, that's a 6, y to the -1 times 2 is -2, y to the -2, all over the 2 to the third, right? 2 to the third. And this is x to the 12th, right? And this is y to the third power. Haha! All right, so far we're doing pretty good. Now we apply the negative exponent rule, and as you can see, we have one negative exponent here, so it flips to the other side. So we get -4 squared x to the 6 all over 2 cubed. You know what? I have to do this. 2 cubed is 8, and I'm just tired of writing 2 cubed over and over and over, so I'm just going to write 8. So 8x to the 12th. Yes, I get tired too. So y to the third, and this y to the -2 is going to go on the bottom and become y squared, right? So this is what I have now, and after I have this, I go for let's see. I go to apply the product rule. So these multiply together, and I get -4 squared. I could probably, you know what? What is -4 squared? Everyone knows. Come on, what is -4 squared? And -4 times -4 is 16, positive 16. There, now we don't have to write it anymore. 16 x to the 6, right? Over 8 x, these two are going to multiply together, 8x to the 12th. And this is going to be y to the 5th, because they add together if you multiply them, right? So at this point, I have this, and then I apply the quotient rule. So I have 6 minus 12, which is going to be to the -6. So I have 16 x to the -6, right? Over 8 y to the 5th. And as you can see, x to the -6, once again, I can't leave a negative exponent, so that becomes 16 over 8 x to the 6 y to the 5th. But that is still not simplest, because 16 over 8 I can simplify. What is 16 divided by 8? 16 divided by 8 is 2. So that simplifies to 2 all over x to the 6 y to the 5th. And you know what's so nice about these problems is when you get done, they tend to look pretty. Let me make sure I got that right. I am not infallible. Last time I checked, so let me just make sure. Let me see. I got a yes, it feels so good. So I got that one right as well. So 2x to the 6, y to the 5th. All right, let's do the last problem that is really kind of mandatory for this, and then we will move on to the next one here. So we have 6x cubed y to the -2 to the -2. That is just a beast. Okay, unfortunately there's no zero exponents here, so no luck, no dice on this one. We actually have to do the problem, so here we go. Let's just delve into it. So we got 6. Once again, I'm doing the power to a power rule first. So 6 to the -2 power, right? X to the x cubed to the -2 power, y to the -2 power to the -2 power, right? All of that, and then I have 3. On this side, I have 3 to the 2 power, x to the 4th to the 2 power, y to the -5 to the 2 power. And I get what is that, Mr. Sims? That's horrible. And I get over 2 to the negative 3 power x to the 4th to the negative 3 power. Hopefully this is just becoming second nature to you. Y squared to the negative 3 power, right? And then what I have to do is just multiply these things. So I get 6 to the negative, I'm just going to leave that. So I get 6 to the negative 2, right? And I get x to the negative 6, right? Because these multiply together. I get x to the negative 6. I get y to the negative 2 times the negative 2 is a positive 4. 3 times 3 squared, right? Times 3 squared. Times x to the 8th. And then that's y to the negative 10. All right. All right. And then all that is over 2 to the negative 3, which is just going to leave 2 to the negative 3. All right. And this is going to be x to the negative 12, right? X to the negative 12, and this is going to be y to the negative 6. All right, now we do the negative exponent rule. The negative exponent rule is going to flip some things around. So what I have here is I have 6 to the negative 2 is going to go to the bottom now. So I have 6 squared on the bottom, right? 6 squared. Then I have x to the negative 6. So this is going to be x to the 6 now. This is going to be y to the 4th. This is going to stay on top. I'm just going to put it right here, y to the 4th, right? I have 3 squared, which is going to stay on top. I'll just put it right here, 3 squared. I'd like to put them at the front, right? I have x to the 8, which stays on top. And I have y to the negative 10, which is going to be moved to the bottom, right? So that was all the top that I just dealt with, right? Now I'm going to do, which ones did I not move? I moved all those on the top. I haven't moved the x to the negative 12 is going to move to the top, x to the 12th, and y to the 6 is going to move to the top, y to the 6. Okay, so I did that there. I did the 3 squared, and I need to do this 2 to the negative 3. That's going to move up to the top as well. That's going to be 2 to the 3rd. I'm just going to put it in the front because I like to have my coefficients in the front. All right, so what I have here is I think I moved everything to the right place. I don't think I missed anything, right? Yeah, I think we're good. All right, just making sure. And let me see now. Now I'm going to do my quotient rule. So I have 2 to the 3rd, which is, I'm just going to leave it like that. So I'm just going to leave it 2 to the 3rd, 3 squared. This is y to the 4th, and there's a y to the negative 10 here. So 4 minus a negative 10. This is very important. 4 minus a negative 10. Oh, I forgot to do the, no, I did it. Why did the, why, oh, this should be, not, sorry, this should be y to the 10th. I meant to make that y to the 10th. Almost made a mistake there, Mr. Sims. You almost lost your 100%. So y to the 10th, not y to the negative 10th, okay? So I have y to the 10th, y to the 4th minus y to the 10th is going to be y to the negative 6, right? I have x to the 8th. I could do the product rule here to put these together before I have to do this mess here. So x to the 8 plus 12 is x to the 20, right? X to the 20, y to the 6, right? And I didn't deal with this x to the 6 on the bottom yet because I was adding these two together. I didn't want to do too many steps in one sitting. So I had x to the squared, and I still have the x to the 6 on the bottom that I have to deal with. So x20 minus x to the 6 is going to be x to the 14, right? Yeah. So that's 2, once again, to the 3rd. Sorry, that got a little bit messy there. That wasn't intentional. 3 squared, y to the negative 6. This is x to the 14, and y to the 6, right? All over 6 squared. Now the nice thing is the product rule, y to the negative 6, y to the 6 here, I can add these two together and that becomes y to the 0 power, which is going to be equal to 1, so it just goes away. So I have, once again, 2 to the third, 3 squared x to the 14th, because the y to the negative 6, y times y to the 6 goes away, and I get all that over 6 squared, and that's going to equal, now I just got to actually multiply these things out. 2 to the third is 8, 3 squared is 9, so I have 9 times 8 times x to the 14th. 9 times 8 is 72, in case you're wondering. 6 squared is 36, and I believe 72 is twice 36, so 72, 36, x to the 14th. This becomes 72 divided by 36 becomes 2x to the 14th, all right? 2x to the 14th, and that should be my final answer. Have I slayed the beast? Where is the problem? I want to see if I slayed the beast. Did I do it? Ha ha! Victory is mine! Ha ha ha! Hopefully you were able to slay the beast as well. Alright, well that's basically where we're going to stop this video. You know what, the Big Mama Jama is here. You are welcome to try this on your own time. It is evil. I have not tried it, and yes, it's evil. But you should have a lot of fun with it. It's actually not as evil as it looks. Go ahead and try it if you want. I always suggest that you do it just so that you can get that extra practice, you know. But if you give me the answer, I don't know. We'll see what happens. So anyway, once again, give it a shot, see if you can do it. And I hope you enjoyed this video. I hope you had a great day today. As always, I am rooting for you. I know that you are capable of so much, and you are truly amazing. You are taking the time to better your education with this. I think that you just keep plugging along, keep chugging along, keep doing what it takes for you to be successful, and you're just amazing for having done it in the first place. Once again, have a great, wonderful day, a great, wonderful week coming up. Good luck on the next test, and I wish you the best of luck in all your future endeavors. Be careful out there.